Hello there and welcome to Lower 6th Further Maths A-Level Pure Core 1 past paper June 2016, and here we're looking at a FP1 question to do with matrices. So first of all it asks us to work out for this matrix here what the geometrical representation is. So what we have here, we can use two pairs of axes here, and we have the coordinate transformation of this one here. And what we're going to do is transform two really easy coordinates that we can work out the multiplication of very quickly. So the first coordinate I'm going to use is the coordinate 1, 0. So that would be this coordinate here. And the second coordinate I'm going to use is this one up here, and that has a coordinate 0, 1. So when you transformed the coordinates, you multiply the matrices together, and luckily what we have here on the right hand side is the identity matrix. So we're just going to get this matrix in front here. So the blue coordinate is going to end up at minus 1 over root 2, 1 over root 2, and the green coordinate is going to end up at minus 1 over root 2, minus 1 over root 2. So the blue coordinate, let's draw out our image coordinates now and see where they end up. Minus 1 over root 2, 1 over root 2, so up here. And the green one is going to end up at minus 1 over root 2, minus 1 over root 2. So we can see here there is definitely a rotation. It's 90 degrees and then an extra 45 degrees here, from this being a coordinate minus 1 over root 2, 1 over root 2. So we have here a rotation 135 degrees from the 90 add 45 anti-clockwise, around 0, 0. Excellent. Let's move on to part B. The transformation U maps a point A with coordinates P, Q to the point B with coordinates 6 root 2, 3 root 2. Find the values of P and Q. So a few ways of doing this. You could think about it as a transformation matrix and doing the inverse of this transformation. So I'll write that out to start with. 1 over root 2 minus 1 over root 2 times by the coordinates P, Q, and you get the answer of 6 root 2, 3 root 2. And all you'd have to do now is work out the inverse of this matrix and pre-multiply it on this side here. An easier way to do this is to think about this as, if I multiply out these coordinates, it'd be 1 over root 2 times P minus 1 over root 2 times Q equals 6 root 2 on the top. If I times through by root 2, I get minus P minus Q equals, times this by another root 2, so that becomes a 2, so 2 times 6 is 12. So P plus Q equals minus 12. And for the second one, it's going to be 1 over root 2, P minus 1 over root 2 Q, which will equal 3 root 2. Multiply this up by root 2 and you get P minus Q equals 6. So if we were to now add these equations together, I get 2P equals 18. So P must therefore equal 9, and therefore, add these two equations together and you get minus 6. So P will equal minus 3. And therefore the Q equation, the Q vector, is going to be minus 9. Okay, so let's see the other way on the calculator, doing the inverse matrices just to check our answers. So input your first matrix. I've used the 1 over root 2 buttons on my calculator when I've input this matrix in. It's just come out in decimals, unfortunately, so we can't really see what's going on there. Put 6 root 2 and 3 root 2 on these two cells here and here on a second matrix. Unfortunately, they've come up as decimals. And then when you do inverse of the transformation matrix times the matrix B then you get the values -3 and -9, just like we did here. Sorry, I got that little accidental bit wrong. Right, so moving on to the next bit, the transformation V represents a 2 by 2 matrix as a reflection in the line y equals x. Write down the matrix Q. So I'll start with my 2 coordinates, much like I did in the first question. So what I'll do is I'll draw out the first coordinate of 1, 0. And if it's reflected in the line y equals x, then it's going to move up to here, 0, 1. And same with the green one, we start with a nice easy coordinate like 0, 1, and if it's reflected in this line y equals x, then it's going to end up on this coordinate over here. So what we get here is our transformation matrix A, which, oh no, it's a Q, isn't it? So Q times by the coordinates 1, 0 and 0, 1 will equal the coordinates, well, the blue one went in first, the blue one's got to come out first, and then the green one will come out next. Good, so seeing that we're timesing Q by the identity here, it's just Q equals 0, 1, 1, 0. Great. Okay, so the next bit is the transformation U is followed by the transformation U followed by the transformation V is the transformation T. The following transformation T is represented by the matrix R. So if we want to do transformation U followed by transformation V, then what we're going to have to do is do the matrix of Q first and then P second. So if we're doing the transformations in the order of P then Q, we write them in the reverse order. A bit like when you were substituting values into, say, FG of 2, you put the 2 into the G one first, and then you put that answer into the F1 next. It's exactly the same thing as what's happening here. You take your coordinates at the back here, you apply matrix P first if you want to do transformation U, and then you apply matrix Q here if you want to perform transformation V. So what we've got here is the matrix of 0, 1, 1, 0 multiplied by -1 over 2, -1 over 2, 1 over root 2, 1 over root 2, and this will give us 1 over root 2, 1 over root 2, wait, hold on, there's a minus down there, so it's -1 over root 2, -1 over root 2 here, and -1 over root 2 here. Okay, you could check it on the calculator, but I'm sure it will come out at that. Deduce the transformation is a self-inverse. So what I mean by self-inverse is that R times by R will give you the identity. So therefore R equals R inverse if you were to pre-multiply or post-multiply by inverse R. So what we have to do is prove this thing here. So what we're going to do is get 1 over root 2 minus 1 over root 2 minus 1 over root 2 minus 1 over root 2 and times it by itself, 1 over root 2 minus 1 over root 2 minus 1 over root 2 and minus 1 over root 2. So just remembering here that 1 over root 2 times 1 over root 2 will give you 1 times 1 is 1 and root 2 times root 2 is 2, so it's yet half here. So let's see what we get when we multiply these matrices together. So we get a half and another half, so that would be 1. Here we get minus a half and plus a half, so that will give us a 0. Here we get minus a half and plus a half, so that will give us a 0. And this will give us plus a half and another plus half, so that will give us 1 here. So therefore, R is a self-inverting matrix. Therefore, the transformation is a self-inverse. Okay, there you are, 10 marks for that question.